Bismillahirrahmanirrahim. My name is Dr. Shagufta Saeed, and presently I am working as an assistant professor in the University of Veterinary and Animal Sciences, Lahore. And the topic of my presentation today is the valorization of indigenous waste plant leaves into optimized biosynthesis of tannase and gallic acid by solid state fermentation, a cost effective approach. Starting from the introduction, gallic acid is basically a phenolic compound that is present in many plants as the secondary metabolite. The pure gallic acid is colorless, odorless, crystalline organic powder that is soluble in alcohol and ether, and its melting point is 250 degrees centigrade. Molecular mass is 170 grams. Chemical formula is C7H6 and O5. The major applications of gallic acid is in the pharmaceutical industry. It is used as the precursor of trimethoprim, antioxidative agent, anti-diabetic, anti-hyperlipidemic, anti-cancer, and it is beneficial for the muscles. The majority of gallic acid produced is used in the food industry as food preservative because of its antioxidant properties. In photography, it is used as a developer and it's also used in the manufacturing of various dyes. The annual demand of gallic acid around the world is approximately 8,000 tons, and conventionally it is produced by the chemical hydrolysis of tannic acid. But this process has some disadvantages like high cost, low yield, low purity, corrosion of the process vessels, and it demands more safety precaution due to toxic effluents that are generated during the process. Alternatively, gallic acid is produced by the microbial fermentation because the microorganisms have enzyme tannase that cleaves the ester bond that is present in the tannin, and it can form gallic acid as well as the glucose molecule. And tannin is present in all the plant parts, especially the leaves that can be damaged by or eaten by the herbivores. These are the example of different microorganisms that have the ability to produce the tannase and the gallic acid, like bacteria, Corynebacterium, and the lactobacillus, yeast like Candida, Saccharomyces, and fungi like Aspergillus, Penicillium, Fusarium. The highest yield is obtained by using the fungus. So we have also used the fungus in our present study. The statement of the problem is that commercial production of gallic acid is done by the acid hydrolysis of tannin that is uneconomical due to the low yield and less purity of the gallic acid obtained. So hypothesis of the present study is that leaves of indigenous plant leaves can be utilized for the production of gallic acid by using solid state fermentation. The objectives of this study are to evaluate the potential of leaves of guava, black plum, eucalyptus, mango, orange, lemon, peepal, and bargate leaves for the production of tannase and gallic acids, and the optimization of physiochemical parameters to obtain the higher yield. These are the materials and the methods: microorganism maintenance, inoculum preparation, and collection of the substrate. And in this case, you can see that the microorganism Aspergillus oryzae was purchased from the first fungal culture bank of Pakistan, Institute of Agricultural Sciences, University of the Punjab, Lahore. It was maintained on the malt extract agar, incubated at 28 degrees centigrade, and then further stored at the 4 degrees centigrade. This sporulated culture of the fungus was picked and mixed in 0.9% sodium chloride solution. It was then further diluted to the concentration of 2 into 10 raised to power 7 spores per ml. Then this suspension can be used for the inoculum in the fermentation studies. Plant leaves of various indigenous plants were collected from the garden and washed with the distilled water to remove the dirt, and then dried in oven at 70 degrees centigrade till it is moisture free, and grinded to make powder that can be used as the substrate for the fermentation. For estimation of the tannin content, the method of Thakur and Nath was used, and after extraction of the tannin from the leaves, the reading was taken at 520 nanometer against the blank, and pure tannin of tannic acid of sigma was used as the standard. For fermentation studies, the substrates of different plant leaves were mixed with the basal media at 1:3 ratio, and the inoculum of 1 ml was added to start the fermentation, and fermentation was carried out at pH 6.5, temperature of 30 degrees centigrade, and for the time of 72 hours. This is the basic composition of the basal media that supports the growth of the fungus. For the optimization of the physiochemical parameters, these are the various parameters that were studied, like substrate water ratio of 1:1 to 1:4, then incubation time from 24 to 120 hours, pH from 4.5 to 8.5, incubation temperature from 30 to 70 degrees centigrade, then additional effect of the carbohydrates and the nitrogen source at 0.2% concentration was also studied. Then after fermentation, the gallic acid were extracted by adding 50 ml of the distilled water and mixing it at shaker at 150 rpm for 10 minutes. Then the mixture was filtered, and the filtrate was preserved for further analysis of the gallic acid by using the method of Sharma et al. And it is also called as the Rodinin method, because in this case Rodinin reagent is used and the reading is taken at 520 nanometer. Then after the optimization of all the conditions, the gallic acid was crystallized by using the oxalate method, and in this case 10 gram of the fermented sample was placed in the Sockless apparatus, and 70% ethanol was run for the extraction for up till 12 hours. Then the extract was filtered and concentrated under vacuum at 50 degrees centigrade. The pure crystals that were obtained by extraction were further, their purity was estimated by HPLC method by using the standard of Sigma Aldrich and the method of Thakur and Nath. All the experiments were carried out in duplicates, and then the descriptive statistics and 1Y ANOVA was applied on the mean value using the SPSS software. These are the results of the study. Like in the first case, you can see this was the Aspergillus oryzae slant on the that grows on the Sabro's dextrose agar. Then in this case, you can see the tannin contents of different plant leaves. You can see that the highest tannin content was reported in black plum leaves, approximately 38 milligram per gram of the substrate. Then in this case, this is the first slide for the selection of substrate, and the highest yield was obtained by using the black plum leaves of both the tannase as well as gallic acid. And you can see from the last slide that as the tannin content in the substrate decreases, same the product yield also decreases by the fermentation. Then the conditions were optimized for the black plum to obtain the high yield of gallic acid and tannase. And by the graph, you can see a substrate water ratio of 1:2, the highest amount of both the products were reported at incubation period of 72 hours. And pH of the basal media adjusted to 5.5 because the fungus grows best at 5.5. Incubation temperature of 30 degrees centigrade, which is very ideal for the fungus. And from different carbohydrates tested, the glucose at 0.2% uh, gave the highest yield. And from the different nitrogen sources tested, the ammonium sulfate at 0.2% gave the maximum yield. This diagram shows the crystals of gallic acid obtained after rotary evaporator that was extracted by Soxhlet apparatus. Then this shows the FTIR spectrum of gallic acid. You can see that the product that is formed is similar to that of the standard, that is the gallic acid. Then the HPLC analysis shows that it is 98% pure in comparison to that of the standard. This is the final table that shows the optimized conditions by using the black plum leaves. There's substrate water ratio of 1:2, incubation time of 72 hours, pH of the basal media is 5.5, incubation temperature of 30 degrees centigrade, carbohydrate source glucose 0.2%, nitrogen source 0.2%, ammonium sulfate. And by following this recipe, you can obtain tannase 179.95 units per gram of the black plum leaves and gallic acid 0.986 milligram per gram. Outcomes of the study is that economical method has been developed for the production of tannase and gallic acid by utilizing the indigenous plant leaves through the solid state fermentation. These are the references of the study, and thank you for your attention.